So this is a little bit change in the topic in that we were discussing, let's see, are we in a particular order? I'll go on this end. We've been discussing aircraft and certification and current business jets. And Kirsten did a really great job this morning talking about the kind of investments that it takes just to get certification. So that's just for the individual airplanes. Now, what we're talking about here, though, in having drones and air taxis, is thousands of more airplanes, which is going to take a change in our national airspace. And so, so this is a great panel here. We have John Damush, who is the Director of New Business Ventures at Boeing Next. Has experience, most of our panel members here have experience in the unmanned aircraft traffic management system. Then we have Ben Marcus of AirMap, also has been working in the UTM space. We have Peter Sachs, Safety and Risk Architect, Airbus UTM, also has been a key member in this area. And I'm not going to go through all their resumes because you guys have them on the app. And then Parimal Kopardekar, which we call PK. I've never had to actually say his whole name. But PK here is like the godfather of the UTM. At NASA, we call them principal investigators. But for the industry, he really brought together a huge community that saw a business case for using drones commercially, but there needed to be some way to organize them safely. And so they've been developing now over the last 4 years. They've had demonstrations of showing more and more complex operations in and near urban areas, and those have been in the news lately. And then we have Michele Merkle, who's Director for Air Traffic Services Operations for the FAA, and has been a part of some of these next-gen airspace concepts and capabilities. So that'll be a great perspective to hear from her of what it takes to really transform the airspace system when we have these, thousands of airplanes already in current operations, and now we need to integrate tens of thousands of more airplanes. Myself, I'm the Urban Air Mobility Grand Challenge lead, and so what we're trying to do there is we're trying to integrate these new aircraft, these eVTOL or STOL, airplanes with airspace providers. So taking some of that idea of what UTM did, of having airspace providers that are helping to supplement safety in the airspace, other than just our typical ATC traffic management, and kind of trying to pull them together early, because right now we have this dichotomy. We have a bunch of people trying to figure out how to fly a distributed electric propulsion airplanes, and that's their main focus, and they're probably looking at the easiest ways to get into the airspace, so just using the current rules of operating. But then you have these airspace providers who they're lacking input on the performance of these vehicles, what their approach and landings look like, what's the crawl, walk, run for them, but they have a long-term goal that they have to start working early. So this is, to transform the airspace system can be like at least 10 years, I'm thinking. So, and to get to these density of operations we're talking about. So we really need the vehicle providers to really start early at thinking about how their operations are going to get more dense. They all want to build thousands of vehicles, but they have to start now working with the airspace partners so that we understand what this operation looks like in our current national airspace. So that's kind of my kickoff to the talk. And so what I'd like to talk with this panel is number one, how do you see UTM affecting some of the ideas of how we integrate air taxis into this market? What are some of the airspace providers in the UTM area considering for air taxis? What information are they lacking? And then we'll go through, that'll start a lot of discussions, and then we can go through questions with everybody. So PK, I'll let you kick it off.
Oh, okay. Thank you. So, thank you for having me on the panel. This is great to be in this nice company. So, Unmanned Aircraft Traffic Management System, or UTM, short form, started really with the idea that we want to make sure that we have operations in a safe manner at the low altitude airspace without overloading the air traffic control system, but maintaining FAA's authority, regulatory and operational authority. What that means is we said we want to not overload the ATC, so not get limited by the workload associated with offering air traffic management services. So we said we are going to do digital, cooperative. We are going to use service-oriented architecture with third-party services, and it's managed by exception. If you look at the current air traffic control, the way it operates is ATC is in the epicenter of every change. Pilot has to get approval or clearance for change in the heading, speed, altitude, and such, which limits the scalability. And partly that happens because only the air traffic control system and a controller has all the information. Now we change that paradigm upside down and saying we will release the information through standardized digital protocols that allows everybody to have that information. Then ATC or ATM's responsibility is to put constraints rather than managing every clearance. So by changing the way we connect everybody, allow that information to be available through standardized protocols, enables us to scale these operations. And we work very closely with FAA to try to make sure that it's consistent with FAA's regulatory authority. That's sort of fundamentally what UTM does. It's digital, managed by exception, clearance, not using clearances, but using restrictions as the means to manage that airspace. And leveraging industry's capabilities, services from outside. Now, fast forward to urban air mobility. So we started with 400 feet and below for drones. Now we are looking at urban air mobility. We're looking at 60,000 feet and up. Different services need to be added, and we'll talk about those as we go along. But that's sort of the introductory primer.
So let me just start at the end over there with John. So how are you guys looking at airspace architectures from drones and moving up into air taxis?
Yeah, so I think the way I'll answer that is start by talking about the existing system, right? I mean, the existing system is pretty amazing when you consider the number of flights that are supported every day. And frankly, when you look at the air traffic control community themselves and what that community has enabled us to go do, and I will say this, in the face of really limiting technologies. There have been a lot of activities in the next-gen offices over the last few decades, but we haven't really seen a proliferation of really kind of what this environment, kind of the tech community is used to in terms of new tech. So when you look at the UTM space, our view is that the value of what PK just talked about is it provides an opportunity and an environment to go try new things in a relatively low-risk environment. If you look at where we are today and the record of safety in aviation today, it's been born of early learnings that unfortunately couple with human life. And that makes it very difficult to iterate in new technology spaces when it comes to airspace management, air traffic management, equipage on aircraft. But this, what I'll call the brave new world of drones, you can do that. And you can do that really rapidly. And you can do it in really controlled and protected environments and start to explore some of the workflows and the ConOps that are involved with the introduction of these new technologies to enable scale and scope in the airspace system, which fundamentally is the challenge. San Francisco had a closed runway for the last couple of weeks, and the reverberations of that runway closure throughout the entire system are significant. So I think it goes to show that as good as the system is today, it is a little bit fragile to shock. So, going forward, how can we use technologies to help with the scale and scope? As you talk about the number of operations that we expect to see, we think you get to a point where you are exceeding the human being's capacity to be part of the inner loop of that system, and you need to find other ways to automate aspects of that. From the Boeing perspective, one of the things that we've done in the last year is made a very significant investment in a joint venture called SkyGrid, which is a joint venture with a company in Austin, Texas called Spark Cognition. Spark Cognition is an artificial intelligence company. So this is our bet towards the fact that we think the solution to the scale and scope problem going forward has to be based in some part on artificial intelligence and the smart application of that to this problem space.
Peter, would you give us your perspective from Airbus?
Yeah, I'm curious, amongst everyone in the audience, how many of you have experience as pilots, air traffic controllers, dispatchers, anything kind of operational? So half-ish, give or take. Think about all the time you spent training initially, training when you changed jobs or changed positions. You probably had recurrent training annually or more frequently. Maybe it was in a simulator, maybe it was in a classroom. In aviation today, we hold ourselves to an incredibly high bar, and the way we achieve the safety rates that we have is with a lot of training and competency and a very closely linked, very involved set of human interactions. Even in a highly automated cockpit, you have to know what those systems are doing. You have to know when the system isn't quite working the way it's supposed to, and you have to know how to handle it. Air traffic control is, in a lot of ways, even more manual. Even as we introduce technologies like CPDLC, there's still a human controller sending that command to your cockpit. The automation that's come on, we call decision support, right? It's not taking away that human controller's role, it's helping them make a good decision. What we're looking at in UTM is a really big leap from frankly, very low levels of autonomy in aviation to very high levels. And this isn't something we've had to do in aviation. This is an FMS on steroids where it's not entirely clear what that FMS is doing, but we all have to trust that it's going to do the right thing and get the airplane or the UAM vehicle to the pad safely. So, for Airbus UTM, this should be scary to everyone in the room a little bit, right? This hasn't been done before. We're operating in a very carefully regulated environment with lots of levels of certification along the way. We certify the people, we certify the vehicles, we certify our air traffic control systems. We use the word a little differently. How you certify it is a little bit differently. But the nice thing, as John said, when we look at UTM amongst smaller vehicles today, we can sort of play in a sandbox where people's lives aren't on the line. You might lose a vehicle if something goes wrong, but it's crashing in an empty field. And this is letting us prove out technologies, because one of the things that has to happen is, we can introduce all the AI we want, but if regulators aren't convinced that those systems will work just as safely as our current system today, we won't stand a chance. So it's really important that we be able to document what we're doing all along the way and take the lessons we're learning from demonstrations and trials and test ranges now to make sure that we're building really robust, tightly integrated systems to ensure safe operations as we go forward.
So maybe I'll start with, why does any of this matter, and why does it matter now? So we're here today, at least I'll speak for myself. I'm here today because I want everybody to be able to benefit from flight on a daily basis, not just a few people who benefit from flight today. And we're not talking about electrifying a few helicopters that fly around today. We want to have a massive number of aircraft flying over our cities, taking people to work, delivering critical supplies, and so forth. There's about 45,000 airline flights a day in the United States. There's 15,000 air traffic controllers. If we want to get to millions of flights a day, clearly that system does not scale. I'll give you a quick little story. Back in 2003, I graduated from college. My first job was selling Cessnas for a Cessna dealer in the Los Angeles area. So I used to fly over the city from one airport to another, give people demo flights. It was really fun. But when I was up there in the sky by myself looking down at the highways, I was like, why am I the only person up here? And all these miserable people are down there stuck on the freeway. That sucks. So I wrote a business plan. I modeled out a business that would fly people to work using Cessna Caravans from all the outlying airports around LA. And I discovered that if I wanted to move 5,000 people a day to work, I needed 191 Cessna Caravans. 5,000 people is nothing. There's about 400,000 super commuters in LA that commute more than an hour and a half each way to work. So 191 Cessna Caravans for 5,000 people. If you've ever flown in the Los Angeles area, imagine putting another 190 aircraft over LA at any given time. If it's visual meteorological conditions and pilots are dependent on see and avoid, there's no way that can be done safely with see and avoid. And if it's instrument meteorological conditions and air traffic controllers have to assure separation, the entire system would come to an absolute standstill. There's no way even 190 more aircraft could be accommodated in the Los Angeles area with ATC. So that's the reason I didn't proceed with the business. It was just no way this was going to work operationally. So imagine now taking that another order of magnitude or 2 orders of magnitude. How do we add 1,900 or 19,000 aircraft over LA? The only way to do it is by totally reinventing how we manage the airspace. And we have to take really bold steps. We can't take iterative steps. I mean, yes, they have to be iterative, but each iterative step has to be bold. And I would argue that the FAA took a very bold and iterative step last year, the first one, which was or 2 years ago, I guess now, to introduce the LANC system, low altitude authorization and notification capability, which is really the first time in the FAA's history that they've allowed third-party providers through a public-private partnership to help operators get air traffic control authorization to fly in controlled airspace. In this case, it was for drones. And it really unlocked a lot of business potential for commercial drone operators, where you previously would have to wait 90 days to get an air traffic control authorization. Now you can do it in about 2 seconds digitally. So those are the kinds of steps that we need to see. We need to see a whole lot more of them over the next 10 years for us to get anywhere close to the kind of scale that all the vehicle makers here want to eventually be able to sell into. And that's what I think all of us are working toward.
Good morning. Thank you for this panel. I'm really excited to be here. So I have been in aviation my entire career, 32 years, and I think this really is the cusp of the next generation of aviation. But I'm really glad to have this panel to talk about airspace because, so it is a crowded sky up there already. We have 5,000 aircraft in the sky at any point in time on a busy day. We move 1 billion passengers a year in the US. But that's by putting them on large airplanes, several hundred of them at a time, right? So now we're talking about private travelers and the potential for, what was the number I heard the earlier discussion, another 7.5 billion untapped private travelers, right? So in the FAA, we've spent about the last 15 years modernizing the air traffic control system through Next Gen. And that's because in 2003, we anticipated that by 2025, we'd have 1.5 to 2 times the number of operations in the NAS that we had at the time. And that was really just manned aircraft. We anticipated UAS aircraft. We thought they would all be large UAS aircraft that would operate like manned aircraft with the same performance characteristics. We thought we would just levy the same performance requirements and all would be good. And instead, we were hit by all these small UAS that we didn't anticipate. So now we have 4 times the number of registered UAS as we have manned aircraft. We're up to about 1.5 million registered UAS between commercial and recreational users. So there is a huge demand out there already, and there is only one national airspace system. And so all these different users add other new entrants, commercial spacecraft as well, right? So we have all these new entrants that want access to that same valuable resource, the national airspace. And so it's really important to bring different players of this community together. I think so we understand what are these different concepts. I heard 200 VTOL concepts was on a slide this morning, so that gives me heart palpitations because we can't accommodate 200 different concepts, so we really need the industry to come together. We need some consensus on how we're all going to work together in the future. And that's both from access to the airspace, operationally, and also from a technical perspective. We have challenges, be it spectrum Again, ADS-B, we thought originally we'd equip UAS with ADS-B. Now we can't do that. 1.5 million UAS out there, we don't have the bandwidth. So, you know, we have to look from both a technical, an operational, and an airspace perspective, how all these new users are going to work together. So I think this is great to have discussions like this in this forum.
Yeah, and so in our NASA Grand Challenge, where when I said we're looking at operations, it's really trying to understand the contingencies that any pilot or operator has to deal with at any given time. So with these electric airplanes, they all have different kind of control schemes. So are they going to be more limited in crosswinds? Are they going to have to be further spaced apart from each other on landing pads? What's their reserves going to be? What's going to be included in their reserves? Is a balked landing or missed approach included in their reserves? And then how far can they go after they've hit their reserve number? So some of these airplanes have 45 minutes of flight. They certainly don't want to have 20 minutes of reserve, which is called out right now. So there's people have talked about, well, maybe we just need 2 miles of reserves, and we have these little emergency lily pads that you can claim, you know, where you're going to land. But when you start listening to the people that build infrastructure for charging stations, it's about $1 million a mile to start moving power into places they haven't been before, and then at the rate at which these need power generation, you're going to have to put in new substations, and that putting in new substations is like probably a 4 to 5 year integration exercise with the whole airspace infrastructure. So I found it really interesting as I've been working with the FAA. We've been working very closely with them. I have about 2 meetings a week, and but you talk to people in the flight standards or people who are doing TERPs for airspace, and really the construct of that airspace is built on the performance of the vehicle. And so most of these vehicles don't want to hover like a helicopter, and you know, they don't want to be stuck to fixed wing coming into a long runway. And so I kind of say, you know, maybe they're not either a good fixed wing or a good helicopter. They're somewhere in between, and you know, it's possible that they're going to need some kind of different approach in landing to what our current fixed wings and helicopters do right now. So if they don't have a landing spot open right when they need to get there, they're not going to hold and hover for traffic crossing. They're going to have some kind of loiter, you know, for the ones that get the most efficiency out of wing-borne flight. And then you have some of them that control themselves like differential thrust or RPMs, and so they're not going to have really good yaw authority, you know, for maneuverability down low and to the ground. So we're trying to understand what these contingencies look like. So thinking of contingencies, I mean, so there's been lots of UTM demonstrations. What are some of the lessons learned in the UTM demonstrations that are gonna, this UAM, advanced electric airplane kind of community are gonna need to know about?
Yeah, certainly. Thank you, Starr. So in terms of where we go from what we are studying in UTM and implementing with FAA and industry's tight collaboration, FAA actually is now in the center of the UTM. NASA's work is primarily getting finished by 2020. What we are learning out of all the trials that we did in coordination with FAA and industry on the UPP, which is the UTM pilot project and such, and our own trials, is there are a number of things that we still need to have really good solutions, otherwise airspace will be somewhat inefficient. So for example, impact of electromagnetic interference on vehicles, the communication, the GPS, degraded conditions, weather is another interesting thing. Now granted, the UTM focused on sub 55-pound vehicles, so urban air mobility is larger and more heavier and different wing loading. But we have studied things where, I'll give you just one example. We were doing testing in Reno, which is 5,080 feet, and it was a hot day. The density altitude already is 5,000 feet, but the density altitude on a hot day was almost close to 8,000, 9,000, depending on the temperature. And then we had headwind. All of a sudden, the battery life shrinks very small. So we all have aspirations to go beyond visual line of sight. but this sort of interesting impact happens because of the environmental conditions. So we all have to take that into account when we are planning your missions or the trajectories in flights as to what will the environment do. Similar things happen when the weather is cold. So interplay of this airspace and vehicle characteristics and capabilities, and then the infrastructure needs is very important, as Starr pointed out. If we have a bird strike and then you need to go land immediately, you need to have that connectivity and information about where is the next possible landing spot available within the time that's available for you to go and safely land. That kind of connectivity and fast decision making needs to happen. What's not available yet is all these requirements. So as Michele pointed out, in order to make these things happen, what do we need to build a system, or how do we make sure that the system is safe and scalable? NASA's focus is primarily on building those requirements through, as Starr mentioned, simulation, flight test, grand challenge, as well as working collaboratively with innovators like you. The main thing that we learned in the UTM trials is collaborative innovation is key. NASA is too fast for FAA and too slow for industry, and that's kind of the right spot in a joking way, where we bring in everybody's talents together and try to make sure that we put the right requirements so that you all can build, investors can have enough confidence that the requirements are right so they can invest in funding. For example, people call me and say, I want to invest in a vertipad company, so I say, okay, what requirements are they building that to? Right? So this is the kind of stuff that we need to make sure that we have done that through the right type of experimentation and understanding of the ecosystem needs.
I guess to echo both what Starr and PK says, I think most of this is actually not a technology problem, but a policy problem. And the technologies, well, you have to do both, but the technologies are relatively simple compared to figuring out how this all works together, which is really policy. And that's really what I think NASA has been an incredible leader and really around the world led the development of the UTM concept. And but as PK said, even NASA is a little bit too slow for industry. So when we get together as industry, when we do things together as industry, when we're given room to experiment at the pace that private sector can experiment, really amazing things happen. One of the policy things that's been sort of holding back the progress of UAS regulations is remote identification. And just in the last 2 weeks, a number of industry players, including ourselves, came together and demonstrated a remote identification protocol, both in California and in Switzerland. And we've now open sourced that protocol through the Linux Foundation. And what we demonstrated was the ability for multiple UTM providers in the same geography to be able to provide services for UAS operators. And any law enforcement official or any other qualified person could use any one of these UTM providers to identify the operator of a UAS operating on any other UTM system. So we show this data exchange. And that's what we've now opened up through the Linux Foundation. So those are the kinds of things that we need to do to be able to harmonize our efforts and push the industry forward.
So I may just add on to that. So, Ben taught that it's a policy issue. I think it's a safety and a security issue. I think those are the big challenges. So safety is the number one priority. We all know that people have a different standard for safety for air travel. It's zero tolerance for fatal accidents. People are much more acceptable of roadway accidents than they are of aviation accidents. So safety is our number one priority, and we still have challenges finding technical solutions to achieve the level of safety that we need. So detect and avoid, beyond visual line of sight. I mean, these are some pretty basic technological capabilities that we still haven't cracked the code on. And then the second item I would say is security. So again, you brought up remote ID. I think that is going to be really the solution at hand for ensuring that we understand who are the clueless, we call them the clueless, the careless, and the criminal that are out there operating. So remote ID will be a way to tell us who's in the airspace. But those two things, I think, are what we really need to have the public confidence to move these concepts forward. There's other things like noise that we are dealing with in manned aviation, and that's not just auditory noise, it's visual noise of having all these new vehicles out buzzing over our heads, particularly in metropolitan areas. So I think those are some of the other challenges that we have to address beyond technology.
Yeah, I would add there's a few foundational technical issues that we need to address, even to crack the nut of BVLOS operations, much less to scale it. We know how to fly precision approaches using GPS today, but guess what? There's redundant systems, a variety of redundant systems on that aircraft, and there's not the space or the weight or even the power available necessarily on a small UAS to do all that today with small devices that'll perform just as well. So, we need to take a really hard look at developing that underlying technology so that we can achieve the densities we envision with equipment that's much smaller, but just as reliable. And that extends not just to navigation, but also surveillance and the communications and data links that'll be used. You need a high assurance, potentially a high bandwidth data link between UTM services and the vehicles in the air, especially if something goes wrong, so that diversions can be safely coordinated. We mentioned that we're not going to be able to use ADS-B out on small UAS. Remote ID might fill some of that need for surveillance, but we're not quite sure yet. We need to prove that out. And if it's not, then what are we going to put on a UAS so that it's detectable by other aircraft or by other surveillance equipment? So those are some of the technical challenges that we really need to be working on.
Yeah, I think I'll foot stomp that, and I'll share a funny story. I greatly admire PK's work, and I think it's interesting. It's made it into the mainstream to a friend of mine who's not in aviation at all, and he made a comment to me. He writes AI code for a very large game company that does massively multiplayer online games, and he said, "Why is this so hard? Like, come on, we do this in the game all the time. Look, I have one operator who's controlling thousands of characters in the game, and the characters are somewhat autonomous in themselves, and they pathfind and they figure out what to go do." And I said, well, that's interesting. One, you've got perfect communication within your game environment between all of the players and the human user. I said, two, none of them ever fail. Like, there's nothing in those systems that report their positions or intents that breaks. And I said, number three, you also don't have potential adversarial entities trying to corrupt your command and control network and change the way all of those actors behave. So it was a bit of an aha moment for him in this discussion to say, oh, I kind of get it. So I think, I completely agree with what Peter just said, in that when you look at trying to do this at scale in smaller systems, certainly you have the reliability, redundancy, supply chain aspects of the equipage that you're going to put on the aircraft. But back to Starr's point about detect and avoid, right now we anchor that on the human. I fly a lot. I'm a flight instructor. I teach people to fly. I'm not very good at that. And when I think about what we need to do to make a system good at that, it really comes down to the awareness of each node in the network, of the other nodes in the network. If we can get to that level of awareness, and I fully support remote ID and the activities that are going on in the space, then I think you start to get closer to that game developer's view of the world, where you can start to have a peer-to-peer cooperative network with some intelligence built into it that allow some kind of self-organization of that traffic. So again, coming full circle back to why UTM is important, this is the environment where we can start to tease out these ideas and experiment with these technologies and start to really put some innovation that comes from the tech world into aviation in a very meaningful way.
Yeah, let me just touch on safety really quick, because I think that today's system is not safe enough for what we're talking about. So helicopters today, let's just say plus or minus, depending on what statistics you look at, have like 0.5 per 100,000 flight hour fatal accident rate. So that means if we want to deploy a UAM system with the existing helicopters that actually scales across the country, you're going to have many, many fatalities every single day from urban air mobility, and that's not going to work. People aren't going to fly on these things. The helicopter airlines that existed in the 60s and 70s, like New York Airways in New York and Los Angeles Airways in LA, both shut down because of helicopter crashes. So I don't think we can rest on our existing paradigm, for example, like any existing paradigm, but especially see and avoid, and say, oh, see and avoid works, so we need detect and avoid. No, detect and avoid, in terms of sensors being on the aircraft, like a pilot size, is not going to be safe enough. So that's why we need a UTM system, and that's why I'm so excited about electric VTOLs, because they can be safer for a couple of reasons. One, distributed electric propulsion is going to reduce the mechanical failure rate of traditional helicopters, and autonomy is going to reduce the biggest cause of helicopter accidents, which is pilot error. I fly helicopters too. So many pilots back the tail rotor into power lines. Like, we can't have that, right? So we need autonomous and we need distributed electric propulsion in order to increase the safety of helicopters by at least an order of magnitude, so that this can be a safe enough system to be scaled.
I'll make a couple of public service announcements here. One is, first of all, we are really happy that the Airspace Operations panel is on the first day and first part of the conference. Usually that didn't used to happen, but 5 years ago, we would be the last panel on the last day of the conference. So this is a good change that we are rallied behind the scalability. Second is, as Starr pointed out, NASA is stepping up Grand Challenge and number of urban air mobility and advanced air mobility related research initiatives. Starr is the Grand Challenge lead. We are also setting up work groups for aircraft, airspace, and infrastructure. So please contact Starr or I to join those work groups. We need your input. We need your participation so that collectively we can actually figure out the requirements through analysis and simulations and testing and other information you have. And we want to accelerate this industry in a safe manner, obviously. We are here from NASA and in tight collaboration with FAA, we are here to help you. At the same time, we need all your participation. We need to understand how you see different business models, different use cases are going to evolve. That will allow us to put the requirements in the right manner. So we are starting up the work groups. We will have a number of opportunities for you to participate in the Grand Challenge that Starr is leading. So please join that as well. And together we're looking forward to continue to work with you.
Can I just add on to, so I too encourage you to get involved. And from an FAA perspective, we'd love that involvement to be through one of the many opportunities that are already out there. We have the Secretary of Transportation's UAS Integrated Pilot Program. We have about 10 of those around the country going on. And whether it's NASA's UTM Grand Challenge or one of the other UTM pilot programs, it is much easier for us to engage with you, with industry, through one of these formalized programs than having each of you coming to our facilities individually trying to test out your new concepts. So I too say go to NASA.
Yeah, so we have about a minute and 30 seconds left. So I wanted to bring up one of these questions, but it made me think of, I think, some of the lessons learned out of the UTM is explaining to this community that is not used to doing IT security plans or cybersecurity plans for all these fly-by-wire systems that are all digitally connected through an airspace system. There are bad players out there, and so that was probably one of the longest poles in the tent of getting industry, to connect to this internet-based system is understanding what it means to do an IT security agreement. Or now with this UAM Grand Challenge, cybersecurity agreements, understanding where all your supply chain is coming from and who's going to put, some bad chip that you didn't know was on there, and how many different things have access to hook into the airplane, and when is the airplane not being supervised, and so there's a lot of things in that world that people aren't realizing is going to be a big hurdle to get the right paperwork in place for that. But it made me think of this question. So are you looking at the feasibility of an aerial 5G network to overcome any of these obstacles? So we talked about ADS-B, not having enough bandwidth, or EMI problems or RF problems. So how is 5G going to help? Does anybody?
Sure, I'll start. Sure. Anything that helps with datacom in an aerial environment is a good thing. Absolutely, let's explore it. My personal experience with cellular technology is not exactly stellar in that I have a lot of dropped calls. So I think when you start to apply that into a safety critical operation, then we have to put some focused energy there to ensure that any use of a distributed cellular network in these operations is done, again, safety first, and then security is a very close second.
Yeah, I think there's certainly a lot of potential for 5G. One of the problems that we're having right now is getting the information that we need from telcos to understand how their network works, even just the locations of their cellular base stations. I can walk around downtown San Francisco and point them out, but I don't know which one's T-Mobile, which one's AT&T, and how exactly they're aligned. Remember, right now our networks are aligned to handle my phone 1.5 meters above the ground, not my vehicle 300 feet in the air. So there's work to be done, and I think it can be done, but we need a lot of help from the telcos to provide more information about how their networks work today and how they're going to work in the future to make sure that we don't run into problems of a vehicle flying near a stadium with 40,000 people looking at their Instagram feeds and disrupting the data link to that vehicle.
These commercial cell phone networks are much more scalable, much more reliable, much more secure than the existing aviation systems. ADS-B, totally unencrypted, totally spoofable. And the way that we communicate today over VHF radio, all you need is another radio to push the mic and not let go, and you've totally blocked the channel. So I think that we certainly need to adapt and make aviation grade some of these commercial connectivity solutions, but I think they're already light years ahead of what we have.
So our time is up. I know there's several more questions, but thank you all for your attention.